Thank you so much, all of you, for joining us today for this second panel. The main motivation for this panel is, well, AI is described often as this double-edged sword, especially for security. It can both identify threats faster, but it can also be utilized as attack vectors as well. So the main motivation for this panel discussion is to discuss about those trade-offs and how we can use AI to better enable security. So I think for our first topic for today, let's just give a quick round of introductions from all of our panelists so we can start off.
Yeah, good to see everyone. Yaoqi here, founder of AltLayer. So at AltLayer, we're providing a bunch of these infrastructure services, for example, rollup as service, EVS as service. And yeah, since around the Q4 last year, we also provide this decentralized AI hosting platform for different agents.
Hello, hi, my name is Neil Fan. I'm a co-founder of Cysic. So Cysic starts by doing some hardware acceleration for zkP, and then I guess starting several months ago, we are providing computing power for almost like every Web3 project, including zk AI and crypto mining.
Hi, I'm Jon. I'm the CEO of Veridise. We perform security services across zk and the Web3 space. And we also build automated tools in order to identify bugs and vulnerabilities in zk circuits and smart contracts.
Hey everyone, I'm Rob Viglione. I'm not up there, so you won't see my picture. I'm a last-minute add-on, so I'm happy to be here. I am the CEO of Horizen Labs and the founder of zkVerify. So we have the coolest stickers in back over there. I mean, great stickers for everyone, but come get some stickers.
Thank you so much. We have a very diverse number of panelists here, so both working on the protocol side, on the auditing side, and on the hardware side as well. So very excited for this panel discussion today. I'm wondering if we can first start off with just a general overview of where AI is most effective in detecting fraud or any kind of malicious activity. But at the same time, what new attack vectors can merge when adversaries themselves, say you use AI for things like phishing or for using deepfakes as well. Are there any examples where, say, our over-reliance on AI right now or potentially even in the future, where security has created these vulnerabilities as opposed to closing them?
You have to audit.
Okay, I guess the consensus is maybe I should start here. So it was a long question, but basically when it comes to AI and security, there's a couple of ways that we've seen AI used in the past. And so AI is a good way of kind of raising a red flag very quickly. And so the nice thing about AI is, like you said, it is automated. It can be used in order to kind of infer information about something that it doesn't necessarily know yet, which is something that can be very powerful, especially for things like phishing and stuff like that. AI, however, is also something that you have to be cautious about because, at least from the security side of things, which is where Veridise comes from a lot, it doesn't provide any sort of security guarantees. So that means that AI can both miss things, but it can also flag things that it shouldn't. And so that means that there are scenarios that you really shouldn't be using AI. And so I know that's maybe not a popular opinion in the days of AI, but really with security, you have to be very careful about how you're using it, especially with the impact that it can have if it doesn't flag something that it really should, especially when there are other alternatives out there. And so, yeah, maybe I'll just leave it there. Does anyone want to add anything?
Why not?
Yeah.
All right, guys. So clearly, AI automates the threat landscape, which sucks for all of us, right? But when we try to automate the defense landscape as well, it's really important that, I guess, one aspect where we can come in on the protocol side is to verify that the AI tool that you're using is, in fact, the right AI tool that you think you're using, including, are all the parameters the right parameters that were used to train that model, or were they changed in some way? If you're running an AI model in a secure enclave, as an example, for some privacy reasons, maybe you're working with data that's healthcare data or some proprietary data, and you can't run that in a public environment. Are you actually getting the outcome or the output that you think you are? Were you actually running it on the right data, with the right model, with the right parameters, and so forth? And that's why, so my company, I guess I didn't do a very good job introducing myself. I was obsessing over the stickers, which you guys should still go get some stickers. But the way we come in is just we deal in cryptography is the bottom line. So my company, we are specialists in zero knowledge cryptography in particular, but also operating in different cryptographic environments and different types of hardware, secure enclaves, and so forth. So where we're trying to tackle this problem is on that one specific niche of, are you actually running the right model? Was it trained on the right parameters, using the right data, and so forth? I do think this is something probably no one thinks about and is actually very important.
Yeah, I mean, making sure that you're running the right AI model is extremely important. You mentioned us seeing new attacks that are making use out of AI. So in the recent past, we've seen malware that's using AI in order to, kind of modify itself and perform actions that are not clearly defined within the malware itself. We're also seeing people attacking AI models themselves, where they might do something like replace the AI model that you're using. And I'm pretty sure that there was an attack that did that recently as well. And so verifying that you know the AI model that's running is very important. And also, just making sure that, you're interacting with a trusted entity is always an important thing and is important with AI going forward.
Can we just say zkVerifying your model is very important?
I'm not here to advocate for anyone. I'm just saying it's important.
zk is certainly one mechanism to do the verifiability. So appreciate how all of us have different perspectives in that area as well. And really great point that you mentioned, John, about some of the limitations with using AI for detection, especially if you are misdetecting or flagging some wrong instances. It could be a little dangerous. And Rob, your points you brought up of verifying that the model was done and also used correctly is also very imperative as well. But just as a follow-up question that I think, John, you posed about how in some contexts AI shouldn't be used, and in some contexts, security-related contexts, AI should be used. Curious to hear from you, as well as all the other panelists, in what context should AI be used, and in what context should it not be used, especially relating to high security related scenarios?
Yeah, so my background is in software security. And so when it comes to software security, you have to be very careful with AI, because there are a lot of alternatives to perform like vulnerability and detection and stuff like that. And so while you should always use every security tool available to you, AI does not provide the security guarantees that other tools that are available can. And so while AI can be used to quickly scan your software, there have been, a lot of studies that you can find published online, which shows that AI is not necessarily good at finding bugs below like surface level bugs, like common vulnerabilities and stuff like that, where it can do some deep reasoning, but still AI is being trained, and it's being trained on a corpus of like common vulnerabilities and stuff like that. And anything that deviates too far away from it, AI struggles a lot more with. And these are things that you can use other tools in order to, provide you with actual security guarantees. On the other hand, a good time to decide to use AI is when there is no other alternative in order to perform a particular action. So in formal methods tools like the ones that we commonly use, AI is very frequently used to search large spaces and stuff like that. And so for these particular problems where it's unclear what other alternatives there are, AI is always a good thing to use, because in some cases it can do very well.
I sort of can give more these kind of real world like use cases and examples, because since last year we've been working with a bunch of partners and projects. They're running all different agents, and we feel that like basically after all these conversation with them, because like last year, Cloud Code and OpenAI doesn't have very powerful code X, right? But for the past few months, there's a lot of sort of code generated by Cloud Code and also code X. And when we talk to these agent sort of partners, they told us like in the early days, they want to have these kind of super powerful agents. So any user can just input what kind of strategy they want. Like for example, I want to buy some tokens. I want to have the highest APY across different chains, right? And like the AI, I mean, behind the scenes, the cloud or OpenAI to really like sort of generate instructions and execute these actions. But gradually they figure out the biggest hurdle right now is not about the model. It's really like how you really scope sort of the questions you ask the AI. For example, if the user just input whatever I just mentioned, right? The problem is like the model will just generate some instructions following the guide, but beyond that, they also overthink a lot and take some extra action. So that part is sometimes very dangerous. So for example, it will do multiple looping for some DeFi pools, and it definitely creates a better API, but at the same time, it can also expose you to more leverage and also security issues. And beyond that, granular, they figure out, okay, the best scenario would be like, we like the AI to generate probably some strategy, but at the same time, if for all the interactions with on-chain protocol, it should be deterministic. For example, these agent partners, they will just predefine a lot of interfaces and make sure like even the strategy generated by AI, it won't really do a lot of these overthinking actions. It can be really properly scoped by the interfaces they provide. That's something at least I learned from these the partners. They already provide these strategies for a lot of users. And beyond that, I believe like if we have a lot of developers, right? Another thing I feel like right now the most important thing is like because we do web coding, and for most of the time this cloud code they will just scan all the files in the repo. In that case, like for a lot of developers, they may also share their private key directly to the cloud. So that's one thing I feel like is super important. For Web 2, probably, you know, right, there's some password for database, but for us, most of the time it's private key. It's more important and crucial. That's something I feel like we should really avoid, or at least instruct the AI don't really touch these private files.
Since like Cysic is not doing anything like related to audit, so I just talk about some my personal experience. So previously, I wrote some papers on using like formal methods to say like to show like some skins or the security proof for some cryptographic skins they are secure. Means like the scientists or the researchers when they are writing the proof, they are actually like doing it in some way. So in that part, since like the search space is quite small, probably like we can just write a bunch of rules and we can just apply some like brute force search, like to search to say like which rule we should apply to carry out the security proof. So that part I don't think like AI is a huge help since the space is very small. You just do some brute force search and you are done with that. Like some of my previous papers say like if you want to carry out a proof for say like 10 to 20 page long proof, like you just need about 2 to 3 seconds to finish the proof on this like, automatic systems. But then the next goal is to show like the security code you write, they are like a functional equivalent to the spec. Since like we are doing a lot of like optimization to make sure like the last optimized version is like very cost effective. And it of course will deviate from the gold standards, the naive basic implementation. So that I think like we can use some like AI tools about that. But since like I'm not in that field anymore, so I'm not sure if any tool has been carried out to verify to security proof that like the optimization you apply for your original code are like sound in these transitions.
So there has been some work in integrating AI into interactive theorem provers in order to do search, because yes, in some cases the search space is very small and people can probably do it effectively, but especially for these like mathlib and stuff like that in Lean, they found cases where the search space was very large because you have to figure out like how you can prove individual lemmas, and they have built in like tactics that use AI to help accelerate that. I think still people writing proofs in Lean tend to solve more problems eventually, but it's a very good way of speeding things up and performing that search process, because writing code in some cases is a search for the right solution. And so
I haven't tried it before. That I'm still in the cock or combo.
I think there's actually a cock tactic as well.
Very interesting to hear just from your side, Leo, and then also John, your side, about experimenting with those, with the assistance of AI, especially in this proof generation context as well. So very interesting to see where these AI tools can be applied to. And then also on your side as well, you presented some use cases relating to AltLayer, and you mentioned how giving users the flexibility of providing their own inputs could have its own caveats as well, especially if the model tends to overthink afterwards. So appreciate all of the kind of insights that you guys gave here. And then I was also curious to also hear about, as we're incorporating more AI into, say, these high security or high security stake systems, how is regulation going to follow along with this? Are there any types of hurdles that we have to go through, or just any kinds of insights that you have like regarding that?
I think at least based on the conversations and policy discussion from the US or different countries, I believe the first or the biggest topic for all the regulators who want to talk about AI is about data. So basically, we all know, right? Singapore, we have PDPA. Like in Europe, we have this GDPR. And US also definitely, they don't want the data to be transferred to the other countries or out of the US. But we all know, like, if we use, for example, Cloud, OpenAI, ChatGPT, right? Most of our data by default will just transfer to their servers. And then so there are two things. One, they claim that they don't use our data for future training, but it's basically trust me bro model. We don't really know. We probably need zk to really make sure okay, the data literally not used for training. But it's probably very difficult. But beyond that, it's also apart from training, right? We just reuse the data for something else. For example, for the recommendation, for example, when we use Google, right? Google always use our search history for better recommendation. But the thing is really about data, especially right now. We web coding a lot of this private information inside the company. Somehow, when we use AI, right, for coding, roughly we share most of the company's information with the cloud or OpenAI. I believe this kind of this data protection and also this copyright, right? Either belonging to the company or belonging to this cloud or OpenAI if they write the code for us, right? So there's a lot of, the boundary is super blurred right now. And the copyright data, who is the real owner, how they really pay for it, or can we really sue them if they misuse our data? These are all the things super sort of blurred at this moment. Yeah.
Do you want to add on to that?
Yeah, that's a great point that you mentioned, especially the blurred lines between data, between copyright, even who owns what. Those are all kind of all instances that we need to further define, especially as we're incorporating AI to these more high security stake systems. But yeah, just off of that, I know there's some talks of just some people mentioning there should be some sort of proof of security, for example, baseline requirements, some kind of attestation that say this AI model can be effectively deployed in this especially in like very high security domains, like say with defense, for example. Just curious to hear about all the panelists here, what your thoughts are on about this. Any sort of baseline requirements that need to be completed before we can start using AI, especially in more like sensitive domains, like say in healthcare or in defense, for example.
Yeah, why not? So guys, beyond getting some stickers at the zkVerify booth, I will say again, like I'm not the security guy on the panel, and I'm definitely not a regulatory guy. I'm not a lawyer. But I do think that we do know some things. So we know AI is here; it's not going away. We do know that a lot more is being audited or being automated, and we even have team members that are vibe coding. So beyond that, we know that we are absolutely going to have very strong security requirements around AI. So not to constantly tell everyone to zkVerify your AI models, but I do think the reality is, depending what industry you're in, you're going to have to protect data. We know that. So that's kind of exists today. We are going to have to, as we use AI models, depending on what you're doing, maybe you need to run it in a secure enclave or some piece of partition software, especially in the national security space. In these types of environments, you're probably going to want to have some sort of assurance that what's happening in the black box is actually what you think is happening in the black box. So from my perspective, as we come back to this question, it's really, how are you verifying that what's happening in that black box is really what you think it is? There's multiple ways to do it. Obviously, we think cryptography is a key component of making sure that that happens.
So when it comes to securing an AI model, there's been some research on that over the past couple of years, but I'm not like an AI security person, so I'm not familiar if there is some work about securing LLMs. As far as I'm aware, there's no work on, making sure LLMs have some sort of guarantee about, like, when someone asks me a question, I'm actually going to do something related to that question. And so the way that I've seen people usually end up providing some guardrails on not necessarily LLMs, but AI in general, is to essentially put what is called a shield in front of the LLM. And so that shield is just a program that has formal guarantees to say, like, I am not allowed to do X, Y, or Z, so that you can say, yes, the AI is going to do certain things. It's got like a specific thing that it wants to do. And so this primarily, the shield thing that I'm talking about was primarily seen in like automated cars, where based off of sensor data, you want to say something like, given this sensor data, this program is going to make sure that the car is turning in safe thresholds and stuff like that. But when it comes to LLMs, things get a lot more difficult because they are so general. And so as far as I'm aware, there's not really a whole lot that you can, or that people are currently doing in order to make sure that an LLM that you're using is actually secure. But when it comes to like, I don't know, military purposes and something like that, they might be able to do something similar.
Yeah, so like as I think, we are also doing something like related to AI security or LLM security, is to say like the first is like we use zk to verify the inference result of some like AI models, which means like if you are asking like your AI model to use say GPT-5 to do the inference, then they are supposed to do that. They are not supposed to use like GPT-3 to do the inference. Since like from a human perspective, we cannot tell the difference. But we use zk to verify, to make sure that they are actually using the model you ask to do the inference. So that's like one thing. The second is like about the AI training part. So like if we also have some like in-house research which we recently like published on ePrint, to say like we want to use like zk to verify the model training purpose, the model training process. They are also legit, which means like you are using the correct way, you are using the correct data set to train the model. So, but it all takes so much long to generate a zk proof. For say like for GPT-5, it's usually like in several minutes to generate a proof. But for this like zk proof for training is like, I guess like more than 1 hour to generate a proof. Yeah.
And yeah, thank you so much for all those insights there. Rob, you mentioned about perhaps running these within secure enclaves. And then you mentioned, John, about having that potential shield as well. And then Leo, you addressed kind of two main aspects that we need to think about for these models, which is relating to the training and inference stages and being able to prove the validity of those two. And even Rob, your point that you mentioned about we need to really see that what's happening inside the black box is actually what's happening, which is very difficult because like for us, we only see the inputs and the outputs. We don't really see what happens in between, but hopefully zk or some other verifiable mechanisms can be used to help assist with that process. So thank you so much for all of our panelists for all the insights. Yeah, really appreciate it for you all for being here.
Thank you.
Thanks.
Thank you, guys.